Alright, the final thing that we need to know about nomenclature in order to finish naming all of our alkanes and alkenes and alkynes is a list of basically all of the functional groups that we might find on these alkanes. So now I'm just going to cover just what those functional groups might look like. And like I mentioned previously, the functional groups are what makes the alkanes reactive. So first, let me start by saying that oftentimes a molecule, a group of carbons, or whatever, will oftentimes be represented just by the letter R. So if we have just the letter R like that, connected to, say, an OH, let's just say, this being the functional group for alcohol, that R means that it could be any alkane. It could be a butane, it could be a butene, it could be a cyclic molecule, it could be anything. It basically just represents that any molecule, like the rest of the molecule that is not the substituent. So, for example, if let's say, for example, there's two groups that you might want to attach to the substituent, you could represent it by like R prime or R double prime if there was three that you wanted to show. And I'll show you how this is in a second. So some functional groups that we might have is, the first one is going to look like this, and R, of course, represents anything and any molecule that could be attached to this. So COOH, that is called carboxylic acid. So that is a carboxyl group, and it's always represented by COOH, and that O up there is double bonded, and that's going to be attached to an R group. R, again, meaning any molecule. So a good example of carboxylic acid would be acetic acid, which is vinegar, and that's one of the simplest ones. The formula for that one is CH3COOH. It looks like this. If you were just to write it out in condensed formula, CH3COOH, that's just acetic acid or vinegar. So that would be a carboxylic acid. Now, like I was talking about the functional group, you see that the COOH is this portion represented here. That portion represented there. That's the COOH. So in this case, the R group is just a methyl group. So, but you know, this could be anything. It could be an ethyl group, it could be a butane, it could be anything. So, but in this particular case, one of the simplest ones, acetic acid or vinegar, is just CH3COOH. So, some other substituents we might have are esters. Esters are like this. You'll have a C double bond O, and then another O connected to an R group, and then another R group on this side. And like I said, if it's two different R groups that it could be, you can represent it by R prime. And this is called an ester. Okay. Amide groups. Amide groups you'll have a nitrogen and a double bonded O. So this is an amide group. Aldehyde. Aldehyde has this functional group on it. You can see these are all kind of similar where they have an R group and a double bonded O, but just take care to note that, for example, this one has a hydrogen here instead of, you know, an OH or something. But the other one that's like really similar to this one is this. It's a ketone. and instead of having a hydrogen there, it has a different R group. So this is an aldehyde, and this is a ketone. So there's lots of substances that we might know about, you know, that we can tell what they are, that maybe they have this structure just because of their name. Like one of the simplest aldehydes that we know of is formaldehyde. Formaldehyde, you know, of course, is used in, you know, preserving flesh and stuff like that. So that one just would have this functional group attached to it, formaldehyde, and again, aldehyde ending, you know that it's there. And a very simple ketone that you might be familiar with is acetone, nail polish remover. So yeah, so that just means that that molecule has that substituent on it like that. And like I said, these two are really similar, but the difference is, you know, this one has the C double bond O connected to an R group and a hydrogen, whereas this one is connected to an R group and a different R group. So yeah, we have that. And then of course don't forget alcohol, which is just OH, like that. Alcohol is just like that. An ether would look like this. It would have the oxygen in between two different R groups. A halide, like I mentioned in the previous video, would just be, you know, any of your elements from group 7, fluorine, chlorine, bromine, and iodine, attached to your alkane. And yeah, I think those are the major ones that you might run into. So just make sure to take note for these things when you are naming your alkanes.